3.3, dividing polynomials. So when you're writing the dividend, you need to make sure that each one of the terms is represented. So we need 3x to the fourth plus 0x to the third minus 6x squared plus 3x minus 7. Now we take the first term in the dividend and the first term in the divisor. 3x squared divided by x is 3x cubed. Then we multiply 3x cubed times each term in the divisor. So 3x cubed times x is 3x to the fourth. 3x cubed times 1 is 3x cubed. Then we change the signs of each of the terms in the second polynomial. So we have 3x to the fourth minus 3x to the fourth is 0. Then 0x cubed minus 3x cubed is negative 3x cubed. Bring down the next term, negative 6x squared. Negative 3x cubed divided by x is negative 3x squared. Negative 3x squared times x is negative 3x cubed. And negative 3x squared times 1 is negative 3x squared. Change the signs of the second polynomial. And we have a negative 3x cubed and a positive 3x cubed is 0, negative 6x squared, and a positive 3x squared is negative 3x squared. Bring down the next term. The negative 3x squared divided by x is negative 3x. Negative 3x times x is negative 3x squared. And negative 3x times 1 is negative 3x. Change the signs of the second polynomial. So this is positive, this one's positive, and we have 6x minus 7. So then 6x divided by x is 6. 6x times x is 6x. 6 times 1 is 6. Change the signs of the second polynomial. And a negative 7 and a negative 6 is a negative 13 as a remainder. Now you can write this as negative 13 over x plus 1. So that's the answer. Now by synthetic division, what you want to do then is to take your divisor, which is x plus 1, and set it equal to 0 so that we get a value here of x is equal to negative 1. That's going to be the divisor. Then we represent each one of the coefficients in 3x to the fourth minus 6x squared plus 3x minus 7. So we have a 3. Then we don't have any x cubed, so we have to put in a 0. Then negative 6 for the x squared term, 3 for the x term, and negative 7 for the constant. Bring down the 3. Negative 1 times 3 is negative 3. 0 and negative 3 is negative 3. Negative 1 times negative 3 is positive 3. Negative 6 plus 3 is negative 3. Negative 1 times negative 3 is positive 3. 3 plus 3 is 6. Negative 1 times 6 is negative 6. And negative 7 and negative 6 is negative 13. Then we write our answer as 3x cubed minus 3x squared minus 3x plus 6 with the remainder of negative 13 over our divisor, which was x plus 1. Okay, so we'll take the first term in the divisor and the first term in the dividend. So 4x cubed divided by 2x squared gives us 2x. 2x times 2x squared is 4x cubed. 2x times negative x is negative 2x squared. And 2x times negative 5 is negative 10x. Change all the signs of the second polynomial. 4x cubed minus 4x cubed is 0. A negative 4x squared and a positive 2x squared is negative 2x squared. A negative 9x and a positive 10x is positive 1x, and bring down the next term. Negative 2x squared divided by 2x squared is negative 1. So negative 1 times 2x squared is negative 2x squared. Negative 1 times negative x is positive x. Negative 1 times negative 5 is positive 5. Change all the signs of the second polynomial, and we have a remainder of 0, so the answer is 2x minus 1. So we take 6x squared and divide it by 2x is 3x. 3x times 2x is 6x squared. 3x times 1 is 3x. Change the signs of the second polynomial. 6x squared minus 6x squared is 0. A negative 1x and a negative 3x is negative 4x. Bring down the negative 2. Negative 4x divided by 2x is negative 2. Negative 2 times 2x is negative 4x. Negative 2 times 1 is negative 2. Changing the signs of the second polynomial, we have a remainder of 0, so we get 3x minus 2. Now, by synthetic division, I have 2x plus 1 equals 0. Solving for x, I get x is equal to negative 1/2. So I'm going to write this in synthetic division. The root or the solution is negative 1/2, and I'm putting the coefficients of each term in the dividend as 6, negative 1, and negative 2. Bring down the 6. Negative 1/2 times 6 is negative 3. Negative 1 and negative 3 is negative 4. Negative 1/2 times negative 4 is positive 2, so I get a remainder of 0. Now this would be 6x minus 4, but because we have a denominator of 2, we can factor 2 out of our solution and get 3x minus 2, which is the answer that we got in long division. So I need to represent the x cubed term in the dividend as 0x cubed. So 4x to the fourth divided by x is 4x to the third. 4x to the third times x is 4x to the fourth. 4x cubed times negative 1 is negative 4x cubed. Then changing the signs of the second polynomial, 0x cubed plus 4x cubed is 4x cubed. Bring down the next term of negative 3x squared. Then 4x cubed divided by x is 4x squared. 4x squared times x is 4x cubed. 4x times negative 1 is negative 4x squared. Change the signs of the second polynomial. A negative 3x squared and a positive 4x squared is positive 1x squared. Bring down the next term. X squared divided by x is x. X times x is x squared. X times negative 1 is negative x. Change the signs of the second polynomial, and I'm getting 3x minus 1. 3x divided by x is 3, and 3x times x is 3x. 3x times negative 1 is negative 3. Change the signs of the second polynomial, and we get a remainder of 2. And we can write this as positive 2 over x minus 1 using synthetic division. I would set x minus 1 equal to 0 gives a root of 1 and represent each one of the coefficients of each term as 4, 0, negative 3, 2, and negative 1. Bring down the 4. 4 times 1 is 4. 0 and 4 is 4. 1 times 4 is 4. Negative 3 and 4 is 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. Negative 1 and 3 is 2. So this would be 4x to the third plus 4x squared plus x plus 3 with the remainder of 2 over x minus 1.